thing. Okay. The second part is I'm going to take x minus, and in place of y, I'm going to drop in this 5 minus x. And then all of this is equal to -3. Okay, so I take one equation. If the first one works nicely, then you take the first one, solve it for a variable, and then take the second equation and literally drop that first equation in. So notice in the y in the second equation, I put a parentheses, and then I dropped in that 5 minus x, which represented my y. And so now what I want to do is I want to simplify. So now we're solving a linear equation. We have just one variable. We've been doing this now for at least 2 days or something. I don't know. It feels like forever. And so I'm going to simplify before I solve. And so I have x minus 5y plus x is equal to -3. Remember, when I simplify, I have to change the sign on both of these pieces because I have this little minus sign out in front. Still simplifying, I have 2x minus 5 is equal to -3. I'm going to add 5 to both sides. I'm starting to skip a few of these steps. So if I add 5 to both sides, I get 2x is equal to 2. Okay. If you need to write that in, go back, put in plus 5, that's fine. Okay. Divide both sides by 2. I get x is equal to 1. That's the value for x, okay? So my solution is going to be an ordered pair. It doesn't matter which one you find first, x is always going to go first. So if I'm getting ready to write my solution here, my solution is going to look like this ordered pair where I know what x is. Now I need to find y. Well, I'm going to go back. So my third step is, so I substituted this in and I solved for x, okay? And so then I have to find the other value. So I have to find y. So I'm going to take my x value and I'm going to plug it into y is equal to 5 minus x. And there's my x value. And so now I get y is equal to 5 minus 1 or 4. And so here is my solution. Here is the lovely thing about systems of equations. You can check it, and that's amazing. So to check it, and I'm going to come down here because I'm always wanted you to be really careful and realize this is not part of my answer. This is checking it. I used the first equation to get this, so it should work. Now I'm going to check this into the second equation. So in the second equation, it says x minus y is equal to -3. So in place of x, I'm going to put 1 minus 4, and 1 minus 4 is -3, and that's what it's supposed to be equal to. Okay? 1 plus 4 is 5, so I can check it in both equations. So always check your ordered pair to make sure it works in both equations. Questions? Okay. So, I'm going to backtrack real quick here. I told you I was going to tell you, it told us to solve by substitution, but a lot of times substitution is really nice if I have either a single x or a single y in either one of my equations. And so that's one reason it told me to do this. It suggested substitution. Some of you might be wondering, well, could I have solved for x? Absolutely, you can solve for x and then substitute that in. You can solve for either one of the two variables. Sometimes one of them is easier to solve for than others. So with that in mind, look at problem number 2. So my system is x is equal to 2y. That's not standard form. It's just the equation of a line here. It's just not in any particular other kind of form. Notice there's no plus a constant or minus a constant on this one, and that's okay. There's nothing wrong with just having an x and a y, okay? The second equation is 6x minus 12y is equal to 6. Well, if I look at this, and I am going to solve this by substitution, I'm going to solve it by substitution, mainly because my first equation is solved for one of my two variables. So I don't have to do that first step here, okay? So I notice that the first equation is solved for y. And so this is, again, this is my first equation and my second equation. And so because the first equation is solved for y, I'm actually going to, my first step in this case is going to be to substitute x into that second equation, okay? So I'm going to drop down here just below this, and I'm going to have 6 and then parentheses, and in place of that x, I'm going to drop in 2y. So 6x becomes 6 times 2y, and then minus 12y is equal to 6. So now I'm going to clean this up, all right? So 6 times, so I'm simplifying, so 6 times 2 is going to be 12y minus 12y is equal to 6. Well, 12y minus 12y is 0, and 0 equals to 6 isn't possible, all right? So sometimes when I'm solving a system of equations, what happens is kind of like when we were solving linear equations the other day, I get this statement that's not ever true. So we call this a false statement. And what this means is that I have no solution to my system of equations. And the other way to write that would be to say I have the empty set. So there is no number which makes this true. If you were to graph these two equations, my graph would be two parallel lines. And because they're parallel lines, they never intersect, and that's why there's no solution. Questions? Questions. Okay, so far so good. All right, so look at number 3 here. One of my two equations is solved for a variable. So again, it may be the first equation, it may be the second equation, but if either one of your equations starts off solved for that variable or a variable, then substitution is really, really nice, okay? And so in this case, here's equation 1, here's equation 2. So what I'm going to do here is I'm going to substitute equation 2 into equation 1. So now I'm going to go the other direction. So my equation 1 is going to become then 5x plus, and in place of y, I'm going to put in, so here's my y, and so I'm going to put in 2x. And all of this is going to be equal to 7. So I'm substituting, I'm replacing this y right here with my 2x. Okay. And so now again, I've gotten rid of one of my two variables. And so now I have 5x plus 2x is equal to 7. And I can simplify before I solve. And this gives me 7x is equal to 7. I can divide both sides by 7. And I get x is equal to 1. If I get a value for either x or y, I'm going to have a solution, okay? So in the first problem, I substituted and I found a value for x, and then I found the value for y afterwards. The second problem, everything disappeared and gave me a false statement, and I had no solution. So again, here, I'm getting ready to solve this. As I work through the problem, I find the value for x, and I say, okay, that means I have a solution. So this means that the solution, because I found x first, is going to be 1 comma something. And so now I have to substitute. So I found, so I substituted this in to find x. And so now I have to find my value for y. And so y is 2 times x, and x in this case is 1, and so I'm going to get y is equal to 2. And so again, because I do have a solution, I can check it. I found the y value using the second equation. So when I get ready to check this, I'm going to check it into the 5x plus y is equal to 7 equation. So I'm going to have 5 times 1 plus 2. Here's my x, here's my y. This is going to be 5 plus 2. And 5 plus 2 is indeed 7, and that's what I'm trying to get. And so it does check in the second equation. Okay. Questions? Okay. All righty. So these next couple of problems, we're going to use the method called elimination. Elimination also is known as linear combinations, adding and subtracting. There's a couple of different names for this. So as we work through this and you go, oh, that's what that is. I don't care whether you know the name of it. It's just that's the name that this book calls it. So the reason it's called elimination is because we're eliminating a variable. And we're actually eliminating a variable by doing something so that we can add the two equations together. Okay. So with elimination, sometimes we have to do some manipulation. If I just took these two equations and added them together, so elimination is also an addition method. So just so that you know why we're doing what we're doing. So, so what we're going to do is we're going to add these two equations together. Don't write this down. Do not write this down because I'm going to erase it through the magic of television. If I were to add these two equations together, I would get 6x minus y is equal to like 53. And that does me absolutely no good. I have x's, I have y's. I didn't eliminate anything. So we're going to pretend like I didn't do this. Okay. What we are going to do is we're going to manipulate one of these two equations so that when I do add them together, I eliminate a variable. Okay. So I need to look at my x's and y's. And I usually try to just eliminate the x's. It's just a little bit easier if you can. If I multiply this second equation by a -2, and you might be saying, why the heck did you choose -2? Because what that's going to give me in my second equation is a -4x. It is going to give me a -8y. It is going to give me a -18. But the -4x is the key element here, all right? I need to have the same number with the opposite sign. So I need my x's to have the same coefficient, one be positive, one be negative. And if I can make that happen by multiplying everything on one equation by something, then that's what I'm going to do. And that's going to allow me to eliminate a variable. And so I'm going to keep my first equation. So 4x minus 5y is equal to 44. But because I manipulated the second equation, now when I add them together, I eliminate my x's. And that was the point here. And so I have 0 x's. I have -13y is equal to 26. Because I added my y's, I added my constants, I added my x's. And now I have an equation. I can divide both sides by -13. And this is going to give me y has a value of -2. And so just like the previous problems, when I solved it, I ended up with a value for one of my variables. Now be careful because I got the second part of my ordered pair. I got the y value for this case. So when I get ready to write the solution, notice that I don't have x, but I have y. And so I found y, and so now I need to substitute back into one of my two equations to find x. So I am going to rely on substitution to find x. So I eliminated a variable and I solved for y, and so now I'm going to pick one of the two equations. So the second part of this is I need to find, the value for x. I'm going to use 2x plus 4y is equal to 9. And so I have 2x plus 4 times negative 2. Let's change that into a nice pink one so we can see where that came from. So 4 times negative 2, and this is equal to 9. And now I have an equation where I can solve for x. And so I have 2x minus 8 is equal to 9. I add 8 to both sides. I get 2x is equal to 17. And I divide both sides by 2, and I get x is equal to 17 halves. And that's how I'm going to write my final answer here. I'm not going to write it as 8.5 or 8.5. I'm just going to leave it as 17 halves, that fraction. Questions? Any questions? Okay. So again, we're going with elimination. This one is going to be different. Okay. And like I said, hopefully this is something you kind of at least feel a little bit comfortable with. You've seen this before. Usually I find that if students remember anything from their high school math class, they remember this and they're like, yeah, I think I got this. So, but we're still going to go through all of these. So don't worry, I'm not leaving you. Okay. So if every term has a number in front, so I don't have a single X or a single Y, I don't have, like in this previous problem, 4 was a multiple of 2, and so I could do that. I don't have that in this problem. So here is the easiest thing to do. Look at the number in front of x in this first equation, okay? And take that number and multiply it times the second equation. Now, notice that I made it negative because both of my x's are positive, so I need one of them to be negative, okay? The next thing I'm going to do is to look at the number in front of x in the second equation. And I'm going to take that number and I'm going to multiply it times the first equation. So I'm going to do 2 times the first equation and 3 times the second equation, but I need one to be positive and one to be negative. Okay? It will always work for elimination. I could have actually done it on the previous problem. I would have just had a little bit bigger numbers to work with, but I would have ended up with exactly the same answer. Okay, so this method will always work for elimination. Take the coefficient of x on the second equation, multiply it times the first one, the coefficient of x on the first equation, multiply it by the second one, making sure that if the original problem didn't have one positive and one negative, that when you multiply one by a positive and one by a negative, okay? So what this is going to give me in the first equation is 6x minus 10y is equal to 106. Multiplying that number through all three pieces, okay? And the second equation, it's going to give me negative 6x minus 18y is equal to positive 90. So again, I'm multiplying that negative 3 times all of my terms. If I'd accidentally done a positive on both of them and I tried adding them together, I'm not going to eliminate a variable. And the whole point of this was the reason this is called elimination is I want to eliminate a variable, okay? So now I'm going to go about solving this. When I add these two together, I get rid of the x's and I end up with negative 19y is equal to 196, okay? And now when I get ready to solve this, I need to divide 196 by negative 19, and it does not give me a nice number. I hope I didn't mess that up. Yeah, so that is not going to be pretty, but it's okay. We've got this. Making sure I didn't do something crazy. Oh, I did do something crazy. Oh, I'm going to see if anybody paid attention to what I did. I made a mistake. What mistake did I make? It's not a whole lot better, but anybody tell me what my mistake is? You can chat it to me, or you can actually just tell me, because I goofed. I goofed big time. I think I'll sit here for a minute and see if anybody can find my mistake. I need to think my brain through. Thank you very much. So somebody corrected me. When I added these, I have no idea where negative 19, I have no idea where negative 19 came from. That is not negative 19. This should be negative 28. That's my mistake for this class. I made a crazy mistake in the first class too. I think it's just like a Tuesday Twitch day or something. I don't know. Anyway, so when I add these two together, I get negative 28. I get 196 here. If I divide both sides by negative 28, I get y is equal to negative 7. Oh, that's so much nicer than what I was going to get. That was going to be really ugly. Okay. All right. So my solution, again, I'm finding the second value for my ordered pair. So my solution is something negative 7. Okay. And so now I need to go backtrack and I need to find x. I'm going to find x. It does not matter which of these two equations you use. It absolutely doesn't make any difference whatsoever. So I'm going to use the second one to find x. And so I'm going to use 2x plus 6y is equal to negative 30. I just picked that one. I like to write down the one I'm going to use so that I know when I go back and look at my work, it's just helpful to me. So 6 times, and my y value is negative 7. And this is equal to negative 30. And so I have 2x minus 42 is equal to negative 30. If I add 42 to both sides, that's going to give me 2x is equal to 12. Right? Just write this in here, add 42 to both sides, add 42 to both sides, add a positive 12 over here, dividing both sides by 2, I get x is equal to 6, and so my point is 6, negative 7. Again, I can check this, so I would check 6, negative 7. I would probably go back and check it in the first equation since I used the second equation to solve. And so this is going to be 3 times 6 minus 5 times negative 7. We're going to have 18 plus 35. And 18 plus 35 is indeed 53, and it does check. So it must work in both equations in order to be a solution for my system. Questions? I should make a mistake every class period and give bonus points to the first person who finds my mistake. Should do that intentionally. Maybe some of you pay better attention. Some of you are paying great attention. You're amazing. Yeah, some of you I think are watching cat videos on the side. I could make a cat video out of my cat. My cat's crazy. All right. Any questions about math? Not about my cat. All right. Again, I'm going to stop. I am tired. I don't think you are tired. So I'm going to make you figure out what I need to multiply the first equation by and what I need to multiply the second equation by. And then somebody's going to tell me. So I'm going to give you like 2 minutes to get this started. Figure out what do I need to multiply on the first equation, what do I need to multiply on the second equation. And then I'm going to ask. I'm going to be quiet. It's very painful. Ooh, that's so close. That's so close. Y'all are so close. I can't type, sorry. Okay, so a couple of folks have told me, and you're actually the people who put in answers are actually correct in that I could multiply by two positives or two negatives. Most of y'all put two positives. But what would I eliminate if I did? Well, we're just not going to do that. So, because I think it gets confusing. So, I've had several people tell me I needed to multiply the first equation by a 5, and that's coming from right here, okay? And the second equation by a 2, and that's coming from right here, okay? The problem is that I end up with a positive 10x and a positive 10x, okay? And so that's not going to eliminate anything. So I need to pick one of those to be negative, okay? So it doesn't matter, but one of them needs to be negative. I'm just going to do the second one as negative. There's absolutely no reason. If, and I'm going to run the risk of making this confusing. So if you got this and you're just like, okay, shut up, be quiet, just don't say anything else. Just tune me out for 30 seconds. If you wanted to eliminate the y's, you could do that. You multiply the second equation by 5 and the first equation by positive 2. So you could do the same thing with the y's, and one of those is positive and one is negative. So you don't have to make, so they already are, you have the same signs. Okay, but we're going to pretend I didn't say that. So we're eliminating the x's. So by doing that, and does anybody have a question as to why I used 5 and 2? Okay, so I'm going to go through and I'm going to multiply this first equation by 5. So I have 10x minus 25y is equal to 250. Notice I'm multiplying that 5 times all of the pieces. Otherwise, horrible things happen. Like the world implodes or turns to dust or something. I don't know. So when I multiply the second equation by negative 2, I get negative 10x minus 4y is equal to negative 18. And now I'm going to add my two equations together, okay? I'm eliminating my x's and see if I can add correctly. And I get negative 29y is equal to big number, calculator time. So 250 plus negative 18 is 232. I hope this is going to be nice. Oh, yes. So when I divide both sides by negative 29, I get y is equal to -8. Watch those negative signs, okay? So y is equal to -8, right? So my solution, again, I found the y value. So the solution is something -8. Again, it doesn't matter which equation you go back to find the y. I'm going to go to the second one. So I'm going to find y, and I'm going to use, excuse me, I'm going to find x. I think I need to go back to sleep today. I'm going to find x by using 5x plus 2y is equal to 9. And so I have 5x plus 2 times, and here's my -8, is equal to 9. And so I have 5x minus 16 is equal to 9. If I add 16 to both sides, I get 5x is equal to 25. Dividing both sides by 5, I get x is equal to 5. And so my solution, 5, -8, is my final answer. Questions? Okay. Very similar question, except I could just multiply one of these two equations by something. Somebody offer me a suggestion. I just want to multiply one equation by something.
The top one by -2?
Yes, we're going to take the top equation and multiply it by -2, because that's going to give me a -10x, so that I have this positive 10x down here, and that's going to be really nice. So sometimes we can just do one equation and not the other, and so that's very helpful. So that is not a positive, that's going to be a negative. So I have -10x minus 12y is equal to -10. My second equation doesn't change at all. It just stays positive 10x plus 12y is equal to 10. Now I add the equations together. I get rid of my x's. I get rid of my y's. I get rid of my numbers. I get 0 is equal to 0. So unlike the second problem we worked, where I got that crazy number of like 0 is equal to 7 or something like that, which was a false statement. Now I got rid of my variables, so I didn't find a value for x or y, okay, like I did on every other one of those previous problems. I found either x or y. This time I got rid of x's and y's, but I made what was called a true statement. So 0 is equal to 0 all day long, every day of the week, 24/7, 365 days a year, even if the sky is purple and blue, okay? It doesn't matter. 0 is equal to 0 is a true statement. So if I get rid of the x's and y's and I get a true statement, a statement which is always true, then this tells me that I have infinite solutions. Okay. And the general way I write this is the general solution way I do this for this particular textbook looks like this. It's going to be a pull down menu or multiple choice, and it's going to have, hey, it's the set of all ordered pairs x and y, so that, and then they're going to write one of these two equations, probably the first one, but it could be the second one. 5x plus 6y is equal to 5. You could have it to look like this. It might say xy, so that 10x plus 12y is equal to 10. Either one of these is an acceptable answer, and only one of those will be there for you to select in a multiple choice format, okay? And even if it's a type in answer format, this would be a pull down menu. Okay. So you're not gonna have to type in all of this crazy math notation. You might simply have to say, hey, it has infinitely many solutions. You may not even have to write a general solution. But if you eliminate the x's and the y's, whether you're using elimination or substitution, it doesn't matter, and you end up with an equation which is true for every value, always true, then you have infinite solutions, and this is one way we can write that solution. Questions? Questions? All right. So again, this time though, I am going to ask you to solve this system of equations. You only need to multiply one equation by something, okay? So I'm going to give you actually a couple of minutes. When you find a solution, I want you to tell me what the solution is. You can just send it to me in a private chat. So you can just chat to me, but tell me what your solution is, okay? And if it's no solution, you can say no solution. If it's infinite solutions, you can just say infinite solutions, or you can give me the x and the y values. You get a couple of minutes. And then I'm going to expect to see answers popping in. Once you find y, find x. Struggling, trying to figure something out. I'm going to give you a hint up here. Answers over here. Y'all are doing amazing things. Okay. Y'all are killing me. You're sending me the answer and a question mark. Confidence, confidence. Tell me, yes, I know what the answer is. Number of question mark. Y'all are faster than I am. Other stuff keeps popping into my world. Y'all are doing great. I'm going to stop you in just a second. Keep going, keep going, keep going. I think I've gotten everybody. So. All right. So let's see how we're doing, because some of y'all are doing some amazing things. I'm just going to let y'all teach. I'm just going to turn the screen over to you if you're doing great things. Okay, so, and you probably then got stuck after you got your Y value. Some of you went on, you got your great X value. So I'm going to tell you how you get your Y value, and then we're going to see what happens from there. So if you multiply this first equation by -3, then that's going to give us that -9x, and that's really what we want to have. So -9x, a plus 6y, and a -3. And so if we take this second equation, just like it is, and now we add it together. So I eliminate my x's, I get 10y is equal to 5, okay? And now I divide both sides by 10. And that's going to give me 5 over 10, which is the same thing as 1/2. Now we really prefer the 1/2, okay? So my solution then is going to be something, comma, 1/2. And we need to find x, okay? So there are a couple of different ways to find x. I'm going to use, I know you don't like this fraction, but it's going to be okay. So I'm going to use the second equation, 9x plus 4 times y is equal to 8. And in place of that y, I'm going to substitute in that 1/2. It's really not that bad when we do this, I promise. So 9x plus, well, 4 times 1/2, what's half of 4? Half of 4 is 2. So this is 9x plus 2 is equal to 8. Subtract 2 from both sides, and this is when y'all started going, maybe I did this wrong. No, you didn't. Divide both sides by 9. You get 6 over 9. 6 over 9 simplifies to 2 over 3. And so my fractional answer, I know you don't like that, is 2/3 and then 1/2. Okay. Question. Some of y'all did a great job. I'm so excited. Some of you flipped some things over, so be really super careful with the making sure you've got your x's and your numerators and denominators in the right place. Y'all are doing great. Okay, I'm gonna give you a check in a second to make sure you're caught up with me. I'm gonna do some fun stuff with these next. All right. So let's see what this has in store for us. This one's a little bit special because we're looking over here and we're seeing that's the same thing over here, but it's different over here. So even if I didn't recognize this, I noticed that this one has a 3x and this one has a positive 3x also. So if I multiply one of these two equations by a negative, it's going to allow me to eliminate my x's. And so my first equation is going to stay the same. I'm going to have 3x minus 6y is equal to 2. Notice though that when I multiply the second one by a -1, I have -3x plus 6y is equal to negative 9. And so now when I add these together, I eliminate my x's, I eliminate my y's, and I get 0 on the left-hand side, and I get negative 7 on the right-hand side. And the last time I checked, 0 was absolutely not equal to negative 7. So this is a false statement. Can anybody remember what happened? We got this a while ago. If I have a false statement, what does my solution look like? Type it, you can state it, you can, whichever one you want to. False statement means what? Exactly. No solution. Solution. Or we can write it as the empty set. Lovely. So if we eliminate everything on one side and we still have these numbers on the other side, so as long as all of our x's and y's are gone, then we're either going to have no solution or infinite solutions. And if we end up with a false statement, it's going to be no solution because we can't have this. If we have a true statement, then we'll have infinite solutions. Excellent. Wonderful. Okay. Ready? Not really. Hang on, we're in for a wild and bumpy ride. Not exactly that close. Not really. Okay. Section 3.3. We skipped 3.2 because we just don't like it. Just don't do it. We skip kind of all over the place. So we have a mixture problem. Did we do mixture problems the other day with just x's? Somebody help me out. Remember doing mixture problems the other day? Yes, no, maybe. Okay, well, I'm going to do these with a box, okay? So if we did these the other day, I probably didn't use a box, but I'm going to use a box with these. So my box is going to look like this. So I can draw this really pretty box because I can cheat and I can draw a really pretty rectangle here. And my rectangle is going to help me come up with my equations, okay? And so in this particular problem, I have one canned juice drink is 20% orange juice. Another one is 10% orange juice. And the question says how many liters of each should be mixed together in order to get 10 liters, that is 19% juice. So I've got a mixture problem, okay? And so for my mixture problem, I'm going to have 3 columns. 1, 2, 3, okay? And I'm going to have 3 rows. So here's going to be my first row, second row, and my third row, okay? And so I'm going to have what I start with, which is my 20% juice drink and my 10% juice drink, and then my mixture, which is 19% orange juice, okay? So that's what it's telling me here. Now, across the top, I'm going to have amount, which in this case is in liters. Okay, so I'm going to put a little L out here so you know it's in liters. I'm going to have percent, and then I'm going to have over here total, which is actually going to be equal to the amount times the percent. Now, because I'm going to have 1, 2, 3%, because I have 3%, I don't have to change these percents to a decimal. You can if you want to. It's totally up to you, but you do not have to. As long as I have 3%, and we'll see some problems in a minute where I don't have 3%, you'll have to change those to a decimal, okay? So in this case, it says, how many of each? Well, here we go. We're going to let this one be X, and this one be Y, and the total is 10. okay? So this first column is going to give me my first equation. And so my first equation is going to be x plus y is equal to 10. So this first column over here is going to give me my first equation. So before I do anything else, I have my first equation. My percents, I'm going to go through, and I have 20%, I have 10%, and I have 19%. So literally, I'm just going to write my percents into that column. And then finally, I'm going to have the last column, which is going to give me my second equation. And this is going to be the total amount, which is going to be the original amount times the percent. So in my first blank, I have 20x. In my second blank, I have 10y. And in the third one, I'm going to have 19 times 10, which I can actually multiply with that calculator, and I get 190. And this is where my second equation comes from. It is going to be 20x plus 10y equals 190. I'm going to stop a second, making sure that everybody's with me. These will have a solution. Questions. Now's a great time to ask a question if you don't know where I got either one of these equations, why I put different things in different boxes. Is there another way to do this? Yes, you have more than one way to do these problems. Neighbor's paper method or Mathway apps are not an option. Most of the apps don't like word problems, I have to tell you that. Okay. So at this point, I can either use substitution to solve this system of equations, or I can use elimination. Okay. Does anybody have a preference as to which method I use to solve this? You can either scream it out loud to me or tell me in a chat, but somebody tell me, whoever tells me first, that's the way I'm going to solve it. Either substitution or elimination. And you can either put S or E in the chat if you don't want to try to spell it. I hate spelling elimination. Substitution or elimination. How are you solving this? Substitution. Okay, first one's first. So actually, I'm really glad you said that, because what this is going to make me do is I'm going to take this first equation and I'm going to solve it for y, and I'm going to substitute it into the second equation. Okay, so I'm going to take this equation and I'm going to solve for y. And so I'm going to get y is equal to 10 minus x. Okay, and now I'm going to take that and I'm going to substitute it into the second equation. So my second equation is going to become 20x plus 10 times y is equal to 190. But in place of y, I'm going to substitute 10 minus x. And for whatever reason, most people really do prefer substitution. I don't know why, but they just do. Okay. And so now I'm going to go about solving this equation. So I'm going to simplify. And so I substituted and now I simplify. So I have 20x plus 100 minus 10x is equal to 190. Simplifying to solve, 20x minus 10x is going to be 10x plus 100 is equal to 190. I'm going to subtract 100 from both sides. I get 10x is equal to 90. And dividing both sides by 10, I get X is equal to 9. Well, it's a good thing it wasn't more than 10 because I would have been in trouble, okay? So be careful because X is going to represent the amount of my 20% solution. So what this tells me then is that I need 9 liters of the 20% juice drink. I need to know how many liters of the 10% juice drink I'm going to have. I am open to suggestions. How many liters of the 10% do I need? Yeah, the 10% do I need? Either a verbal answer or a chat answer. Close. Think about the fact that I have to have a total of 10. If you're trying to figure out what this is, think about how much I need to have of the 10% to get a total of 10. Yes. Yes. I know, I'm not telling y'all what it is. I'll tell you in a minute. Okay. So what I'm doing here, I found X was 20%, and now I need to find Y. So the 10% is the Y value. So I find Y by using, and I can go right here, or I can just say, hey, that was 10. 10 minus 9 is 1. So I can use Y is equal to 10 minus X, and therefore Y is 10 minus 9, which is 1. Or I can just say, I think I got this. And so 1 liter of the 10% juice drink is what's needed. Questions? Questions, questions. Okay. So this one is a little bit tricky, but it's the same idea. So pure acid is added to a 10% acid solution to get a 90 liters of an 87% acid solution. What amount of each solution should be used? So again, I'm going to do a box. And I'm going to use the box to help me set up my equation. And so I'm going to have columns. And I'm going to have amount, which in this case, again, is going to be liters. I'm going to have percent, and I have 1, 2, maybe 3%. We'll talk about that in a second. And then this final one is going to be amount times percent. I have, can't write, I have pure acid. I have a 10% solution, and I want to get a mixture, which is 87%. What is, see if y'all paying attention here. Here is my 10%. Here is my 87%. What's the percent of my pure acid? 100%, exactly. So pure acid is 100% acid, okay? So be careful, make sure you realize we do actually have 3%, okay? So now I'm gonna go through, and it doesn't really matter, I'm just listing them in order. So this first one I'm going to call X, the second one I'm going to call Y, and my mixture down here is 90 liters. And so I can go ahead and multiply this together to get this third column. And so this is going to be 100X plus, and then I'm going to have this 10Y. So I'm multiplying that. And then finally, I'm going to have 90 times 87. I'm so not doing that without a calculator this morning. So 90 times 87 is going to be 7,830. All right, so I have my box completely filled out. And now I need you to write your two equations. Okay, I'm going to give you just about a minute to see if you can write your two equations that we're going to use, and then we'll solve that system of equations. Remember from the previous problem, which columns are going to produce for me equations? Hopefully, write these down and you look up at the screen. And you can see what you should have. And hopefully you remembered that my first equation comes from my first column, and my second equation comes from the third column, and there's just great information here in the middle. All right. Just because of something different, I'm going to solve this system by elimination. And I'm going to solve it by elimination by multiplying the first equation by negative 100, so then I can get rid of the x's. Just a little bit different technique. If you want to solve by substitution, solve the first equation for y and go for it. It'll be amazing. You will get exactly the same answer that I get, okay? But I am going to go through, and like I said, I'm going to multiply this first equation up here by negative 100. And so that's going to allow me to eliminate my x's. That's going to give me negative 100x minus 100y is equal to negative, and I can count zeros. I have 3 of them, so I have negative 9,000. My second equation is going to be positive 100x. It's going to stay the same. Plus 10y is equal to 7,830. And so now I'm going to add the two equations together. When I add these two equations together, I get negative 90y is equal to negative 1170. I do want to point something out to you here. If you accidentally lost a negative sign and you get y is equal to a negative 13 rather than a positive 13, I hope you know that there's a mistake, because I can't have a negative amount of a solution, okay? So be careful there. So I need 13 liters of the 10% acid solution. To find how much pure acid I need to substitute. I would probably substitute into this. So to find y, excuse me, to find x, because we found y, to find x, I would think x plus y equals 90. You may not even have to actually substitute this in. You may simply say, okay, it's going to be 90 minus 13, and that's going to give me 77. So 77 liters of pure acid. You add these together, you should get a total of 90. That's what I need. Questions? little suspicious. I'm thinking people want to sleep on me. Okay. So another type of mixture, and this is our investment problem, and I'm pretty sure we talked about interest the other day, but if not, I'm just going to remind you, interest is equal to principal times rate times time. So $9,500 is invested. Part of it is invested at 11%. Part of it is invested at 6%. For a certain year, the total interest, for a certain year, the total interest, I don't know why that says year there. The total interest, sometimes I can't type, is $865. How much was invested at each rate? So since we're talking about for a year, then this tells me that time is 1. And so I can translate this into interest is equal to principal times rate. And I know we did these the other day with the box. And so the same problems that we did the other day with the mixture and the containers and the box that we did today, you can do both of these, the ones the other day without X's and Y's and the ones today with X's and Y's. You can solve both of them the same way, whichever way you prefer, or you can solve them 2 different ways. It's totally up to you. So just giving you some options here. So again, I'm going to do a box. And remember that in this box, I flip-flopped my formula around, and I had principal and rate, and then interest is equal to principal times rate. Time again is 1. And so I had the 2 different amounts. So I have, this is my total, whether it's my total principal or my total interest. And I have the amount that was invested at 11%, and I have some amount at 6%, okay? Now here's where we're gonna have to be careful. Notice there are only 2%. So because there's only 2%, my percent has to be written as a decimal. So keep that in mind, okay? So 9,500 is invested. That is my total amount of my investment. Okay. One of these is going to be X and one of them is going to be Y. It doesn't matter. So I'm just going to let the first one be X and the second one be Y. Remember, I'm going to go ahead and write my equation. I have X plus Y is equal to 9,500. That's my first equation. That first column still represents my first equation, okay? Might as well go ahead and do that. We talked about that. It works the same for the mixture problem. The decimal, however, is where we've got to be careful. So 11% translates into 0.11. Remember, we're dividing this by 100. 6% translates into 0.06. Okay, dividing it by 100, moving the decimal 2 places. Here's what I don't have. I do not have a total percent. And that's why this is important that you have to have the decimals here. Okay. And then finally over here in my last column, I have 0.11x. I have 0.06y. And I actually have a number for my total interest, and that is 865. Okay, so that's the difference between the mixture problems and the interest problems. Is I don't have a percentage rate I don't have a percent for all 3 pieces. I have a beginning amount, I have an ending amount there, so I have to translate those into decimals. Okay, so the last column again is going to be my second equation. So I have 0.11x plus 0.06y equals 865. Now, this is one of these problems. You have a couple of options here on this problem. You can get rid of the decimals if you want to. At this point in time, because we let you use a calculator, most people are like, yeah, well, the decimals really don't bother me. So you don't have to get rid of the decimals. If you do want to get rid of the decimals, you multiply every piece by 100. The problem with it is it gives you a big number here, but that's up to you. Most people prefer to solve this by substitution, so that's the method I'm going to use here, all right? So that means I'm going to take this first equation and I'm going to solve it for y. And so I'm going to have y is equal to 9,500 minus x, and I'm going to substitute that into my second equation. So my second equation is going to be 1100 x plus 600 times y is equal to 865. And in place of y, I'm going to substitute 9,500 minus x. And so my second equation is going to become 1100 x plus, so pulling out the calculator for these, y'all know I don't like these decimals, 9,500 times 0.06. So I'm going to have 570 minus, and I'm multiplying everything through by that decimal, 865. Simplify before I solve. This is going to give me 0.05x plus 570 is equal to 865. Use your calculator. These are very messy numbers, okay? So subtracting 570 from both sides. So I'm actually going to write that in there for you because I know we're starting to get pretty messy here. Subtracting 570 from both sides, I get 0.05x is equal to 295. Here I am going to divide both sides by 0.05. I know with these decimals, sometimes y'all don't like those, but I think most y'all are okay with that. It has to be negative because otherwise I'm going to get a negative answer, and that's not going to be. That is not negative. That's a decimal. Don't listen to me. That is a decimal there. I'm going to say we're fixing to have some funky stuff going on here. That is 0.05 divided by 0.05 divided by 0.05, and that's going to be 5,900. What is 5,900? I need some help here. I don't know what I found. It's right. I just don't know what I found. I do, but I need to know if you know what I found. What does 5,900 represent? Other than X, and don't tell me X.
The total amount that was invested.
At which percent?
11.
At 11%, exactly. And I know that because my box, my X is in my 11% row, okay? So 5,900 was invested at 11%. How do I find the amount that was invested at 6%? How do I find that second amount? Or somebody can just tell me what that second amount is. That's okay too. So close. Ooh, I know what we're doing. Okay, so yeah, there you go. Okay, so it's going to be, it's the y, it's the, I found x, I need to find y, so I can simply subtract it from 9,500, and that's going to give me $3,600 was invested at 6%. Okay, The sum of these two has to be the total amount that was invested. So I can either go back and plug it into here, or I can just think 9,500 minus 5,900 gives me 3,600. Questions? Well, we only have 30 more problems to go, so we should be good. See if y'all are really paying attention, if anybody printed off notes. Okay. So we have one more mixture problem, and then we've got one other type of problem. We really just have two problems left. So bear with me, concentrate with me, and see, this is why I decided it was not a good idea to do something completely different after this, but I figured y'all's brains were going to be good after this, okay? So I would like for you to, I'm going to set up the box. We're going to do the same thing. So we've got a store that's going to mix two different types of grass, a red fescue, which is worth $10 per pound, and a ryegrass, which is worth $14 per pound. The mixture is to sell for $11 per pound. And we want to know how much of each we need to use to make this 312-pound mixture, okay? So those of you who are hunters, you might plant stuff out there for the poor little deer to come and feed on, so you can like take advantage of the fact that they're standing there eating your grass. Or maybe you're like a turf grass management person and you want to figure out how to mix the grasses. Or, you know, if you don't even like grass, you can turn this into chocolate and peanuts, or you can turn it into coffee. You can mix all kinds of things. We just happen to be mixing some grass here, okay? I don't know what red fescue looks like, but I know what ryegrass looks like. Okay. So let's do a box, okay? And so we're going to do exactly the same thing, except I'm going to see if you guys can fill in some information here for me without me doing it. So my first column is going to be amount, and this is going to be pounds in this case, not liters. I don't have a percent. So instead of percent, I'm going to use price. They both start with P, so that makes it very nice, okay? And then the total over here is going to be the amount times the price. All right. So I'm going to be quiet in just a second. So I have the red fescue. I have the ryegrass. And I have my mixture. Okay, go for it. See what you can fill in the blanks. And then we'll kind of come up with something together. I can play the Jeopardy music. Da, 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 da. Don't watch cat videos. Watch grass grow. That's the only thing. Okay. So those of you who are not writing things down and who are watching your videos or you're listening to something else, come back and pay attention to me. Okay. I'm going to let X represent the amount for my red fescue. I'm going to let Y represent the amount for my ryegrass. Somebody tell me what value goes in the mixture amount. 312, exactly. So 312 is my mixture, okay? So my first equation is going to be X plus Y equals 312. That's my first equation, right? You might can get this without the box. I like the box. I like to be organized. That's just my life. I'm sorry. Okay, so now I want to know what price is going to go in this first box, the red fescue box. What's the price that's going to go here? Open to suggestions. 10, exactly. Thank you very much. What's going to go in the price for the ryegrass? 14, perfect. And what is going to go in the price for the mixture? 11, excellent. Okay, I'm loving this. I'm getting lots of responses. That makes me so happy. Okay, so now to get this last column over here, which is what's going to give me my second equation, I'm going to multiply. So 10x plus 14y is equal to 312 times 11. So that's going to be 3,432. And so there is my second equation. So I have 10x plus 14y is equal to 3,432. All right. Anybody have a preference as to how I work this problem? I have a personal preference, but it might not be your preference. So substitution or elimination. Somebody suggest it or type it or something. Substitution, excellent. So that's not my preference, but that's okay. I knew that's what your preference would be, y'all's preference would be. So I'm going to take the first equation and I'm going to solve it for y. So y is equal to 312 minus x. Somebody might be asking, why do you always solve for y? I have zero reason for it. I just do. That's it. That's the reason. I don't know why. It just happens. Okay. All right. So the second equation now is going to become 10x plus 14. We're going to drop that y value in is equal to 3,432. My y value being this 312 minus x. You could solve for x if you wanted to and substitute it in there. It does not matter. Okay. All right. So I have 10x plus large numbers make my head hurt today. So 312 times 14 is going to be 4,368 minus 14x is equal to 3,432. All right, simplifying again. So this is going to give me negative 4x plus 4,368 equals 3,432. Now here's where we have to be careful. I'm going to subtract 4,368 from both sides, which is going to give me negative 936. And if I lose this negative that's attached to the 4, I'm going to be in trouble because I'm going to get a negative number of pounds. Guys, that is not happening. So don't get negatives on these. Please don't get negatives on these. Divide both sides by negative 4, and I get x is 234. So x represents the amount of the red fescue. So that means I need 234 pounds of red fescue. And I need how many pounds of ryegrass? How many pounds of ryegrass do I need? Somebody help me out. I know the total has to be 312. And I know I have 234 pounds of ryegrass, of fescue. So how many pounds? There we go. I got 78 pounds of ryegrass. Questions? See, look, this is relevant to something, kind of, sort of. It's like a real practical application problem. I know you don't care how much grass we use, but I care. Grass is important. Without grass, we don't have things growing. How did I get that? Okay, it was magic. No, I'm just kidding. Okay, so make sure you understand that X was 234. Okay, let's go back up here. If Y is 312 minus, and my X value is 234, then that's going to give me, if I subtract and I subtract correctly, I'm hoping whoever subtracted with me while ago subtracted correctly, I get 78. Does that make sense? I have a question. So if the person who asked it, if that doesn't make sense, okay, perfect, excellent. All right. Oh, excellent. We just have one more problem. And we'll be done with application problems. I think to the end of ever. Maybe. Okay. All right, so this is a little bit different kind of problem, and we can also use a system of equations to solve this. All of these problems we can solve other ways, but this one in particular lends itself very, very nicely to a system of equations. So we look at this problem. It says there were 323 tickets sold for a basketball game before March. Anyway, student tickets were $1.75 each, and the adult tickets were $2 each. The total amount earned from ticket sales was $598.75. I don't know when the last time you could go to any kind of game for $1.75 was, but anyway, that was back like when I was a kid, so that was dark ages. How many of each kind of ticket was sold? So, like I said, this is a little bit different kind of problem. You can do this with lots of different types of things. So I need to know the two different types of tickets I have. I have student tickets and I have adult tickets. So two different types of tickets. So student tickets and adult tickets. And I am going to let X represent one of those and Y represent the other one. So I'm going to let X represent the student tickets and Y represent the adult tickets. And so I'm going to have my two different equations are going to be based on, one of them is amount and one of them is money. And so the first equation has to come from adding the student tickets to the adult tickets. And that total is somewhere in this problem. Can somebody tell me what X plus Y has to be equal to? Think about the fact that that's a money amount. And here I'm simply talking about the number of tickets. Yes. Okay. So I got several people who told me it's going to be 323. And so this is one of these things where you're starting to pull out information. So I'm talking about total number of tickets. And so this is tickets for this is tickets for this piece. And so that's going to be my total number of tickets. My second equation is going to involve the money amount. Okay. And so for the student tickets, what I get from each student ticket is $1.75 times the number of student tickets sold, plus $2 times each adult ticket sold. And this is going to give me a total of $598.75. So one thing I try to tell students is money goes with money, amount goes with amount. Okay. So somehow I've got to incorporate the $1.75, the $2, and the $598.75. And so that's what that second equation is going to be. Okay. I know before I even ask y'all what you want me to do, and that is solve by substitution, because y'all just love substitution. It's okay. So I'm going to solve this for Y. So 323 minus X. Second equation, 1.75x plus 2 times y, and y is 323 minus x, is equal to 598.75. And now I have my linear equation to solve. Yay. I know we've done these all the same way because they all will work the same way. That's one of my favorite things about these problems is they are very, very, very consistent in how you work them. So 323 times 2, I can't even do that right now, is 646 minus 2x is equal to 598.75. Simplify before I solve. So I collect my x's together. I get negative 0.25x plus 646 is equal to 598.75. Subtracting that from both sides, it's going to give me negative 0.25x is equal to, watch out because you're going to have a negative here, negative 47.25. And then when I divide both sides by negative 0.25, I'm going to get a positive 189. So this tells me that 189 student tickets were sold. The question is, how many adult tickets were sold? Somebody tell me how many adult tickets were sold. Yes, 134. Just saw it pop up over there. Excellent. Yay, several people got it. Fabulous. And we get that by subtracting from 323. Are y'all worn out? I'm worn out. That's the last problem I got for you. Questions? Somebody's already left me because you got bored. Okay. All right, guys, this is it. This homework assignment is now due on Thursday, not tomorrow. Gives you a little bit of time because you can see these problems take a little bit of time to work. So please work through the homework, get a good grade on the homework before you take your quiz. And then we'll knock out chapter 4 tomorrow. So if you got any questions, stick around, ask me, send me an email, send me a private message. We're good. Happy Tuesday.